Welcome to clickmyproject.com. Let me discuss about the project Secure and Efficient Data Transmission for Cluster-Based Wireless Sensor Networks. Let me discuss about the abstract of the project. Secure data transmission is a critical issue for wireless sensor networks. Clustering is an effective and practical way to enhance the system performance of WSNs. Proposed a CRP for secure data transmission for cluster-based WSNs where the clusters are formed dynamically and periodically. CRP uses digital signature scheme and the identity-based online or offline digital signature scheme. For security, in DSI, security relies on the hardness of the defined element problem in the pairing domain so that it uses a hashing technique for signing and verification. In DSOO, it reduces the computational overhead for protocol security, which is crucial for WSNs, while its security relies on the hardness of the discrete logarithm problem. To improve the performance of the system, energy-aware rule-based scheme was proposed. Simulation results shows that the proposed scheme has better performance compared with the existing system in terms of security, efficiency, energy consumption. A digital signature is a mathematical scheme for demonstrating the authenticity of a digital message or document. A valid digital signature gives a recipient reason to believe that the message was created by a known sender, such that the sender cannot deny having sent the message. It is authentication or non-reputation, and that the message was not altered in transmit. Digital signatures are commonly used for software distribution, financial transaction, and in other cases where it is important to detect forgery or tampering. Digital signatures employ a type of asymmetric cryptography for messages sent through a non-secure channel. A properly implemented digital signature gives a receiver reasons to believe the message was sent by the claimed sender. Digital signatures are equivalent to traditional handwritten signatures in many respects, but properly implemented digital signatures are more difficult to forge than the handwritten type. Digital signature scheme in the sense used here are cryptographically based and must be implemented properly to be effective. Digital signatures can also be provide non-reputation, meaning that the signer cannot successfully claim they did not define the sign of the message means secret. For the some non-reputation schemes offer a timestamp for the digital signature so that even if the private key is imposed, the signature is valid. Digitally signed message may be anything representative as a bit string. Example include electronic mail contracts or a message sent via some other cryptographic protocol. Let me discuss about the flow diagram for our process. In the random node deployment, randomly deployed wireless sensor plays an important role in quality of methods used for data acquisition and signal reconstruction. Mathematically speaking, the estimation of distribution of randomly deployed sensor can be related to computing the spectrum of van der Waals matrices with non-uniform entries. The randomness of the deployment of sensors may have several reasons. For example, a case of practical interest is when wireless sensors are released from an airplane at fixed intervals but happen to land on Earth with random positions. For a given distribution of randomly deployed sensor, one would like to infer on the distribution of the sensor. The effectiveness of the DSN is determined to be a large extent by the coverage provided by the sensor deployment. The positioning of sensor affects coverage, communication cost, and resource management. In this paper, we focus on sensor deployment strategies that maximize the coverage for a given number of sensors within a cluster in cluster-based DSNs. Also, the target are deployed randomly. Next, in the genetic algorithm phase are proposed. Before that genetic algorithm, we need to initialize the set IBS protocol. Here, date node identification and also cluster are formed. Based on the genetic algorithm or family of computational models inspired by evaluation. These algorithms encode a potential solution to a specific problem on a simple chromosome like data structure and apply recombination operator to these structures so as to preserve critical information. A solution generated by genetic algorithm is called a chromosome. While collection of chromosome is referred as a population, a chromosome is composed from genes, and its value can be either numerical, binary, symbols, or characters, depending on the problem want to be solved. Next, in the distribution to member node, proposed system implement two secure and efficient data transmission protocols for CWSNs called DSI and DSO respectively. The key idea of both the DSI and DSO is to authenticate the encrypted sensed data by applying digital signature to message packets, which are efficient in communication, and applying the key management for security. In the proposed protocol, secret keys and pairing parameters are distributed and preloaded to all sensor nodes by the BIS initially, which overcomes the key problem. Next, in the transmission phase, the proposed system uses the homomorphic encryption for encryption the data packet and uses the hash function for identifying the varying length and digital signature scheme for authentication. If the authentication is successful, then it sends the data packet through the labeled routing path. Finally, we achieve the maximum network lifetime based on the set IBS protocol. Let me discuss about the running procedure for our process. Select the main.temp file in the current folder, right click that file and run for executing this process. This is the main window of the secure and efficient data transmission. Here we need to enter the number of nodes to be deployed. And by pressing the node deployment button, we deploy the every nodes in the coverage area. Here the coverage area mentioned as the size of 100 cross 100. And by pressing the target deployment, we deploy the target in the coverage area. Here I declare the target location. And by pressing the genetic algorithm button, we can perform the genetic algorithm simulation approaches. Here this is the optimum tool for genetic algorithm. Here we need to mention the fitness function for our process, and here we need to mention the number of variable to be used for the genetic algorithm optimization. By pressing the start button, we perform the optimization algorithm. Here we obtain the optimum value. After that, we perform the cluster head process. Here the dead node identification and also the cluster head selection will be repeated for every iteration. So this algorithm will be repeated for among all clusters. Every cluster head transmit the data to the target and based on the secure transmission. So here the secure transmission algorithm will be proposed. That is, we need here data will be encrypted with digital signature and transmitted to the target. This process will take some time for executing. After completing the cluster head process, here we need to estimate the maximum iteration. By pressing the maximum iteration button, we calculated the maximum iteration for directly from cluster head and also through cluster head. Here we obtain the maximum iteration level. This process will take some time for executing. Finally, we obtain the sensed data for 100 sensors and also the encrypted data for 100 sensors. And here maximum iteration level we obtained. By pressing the analysis button, we perform the comparison graph. This is a comparison graph between maximum iteration as well as number of nodes for method 1 and method 2. Method 1 means directly transfer to from cluster head to base station, and method 2 represents the transfer data to base station through various number of cluster head, and as well as the comparison graph for average energy versus number of nodes between method 1 and method 2. In this cluster-based algorithm can effectively implement with genetic algorithm. The sensed data are transmitted securely by the encryption scheme. Thank you.